Hey guys, and welcome back to a new Jetpack Compose tutorial. In this video I will show you how you can implement pinch to zoom gesture in Compose and how you can also rotate an image. So you can see this is the image I have here, and if I pinch then I can actually zoom in, and if we're zoomed in we can also move the image until we reach the bounds, but not past that. And in this video you will learn how you can achieve this behavior in your Android app. So here in this empty project, we just want to have one state for the scale of our image by remember, import, remember, why doesn't it show up here? Remember, I don't know, by remember mutable state of. Initially our scale is 1f, and hopefully we can now hit Alt Enter to import that. No, we can't. Now I can, okay. Compose is weird today. Alt Enter, import that again, Alt Enter again, and then we have this by delegate as well. And we can reuse this for our offset as well. So our offset is, it basically describes where our image currently is. So when we zoom in and we move the image, then we change our offset by moving it. By default, it's at offset.0. So just 0 pixels on the x-axis and 0 pixels on the y-axis. We can also add rotation here, but for the use case I showed you, we don't really need this. You can't really rotate an image in your gallery, but after I showed you all that, I will also show you what you could do if you would really want to rotate something, because that's really pretty easy to extend this functionality. What we then need is a box with constraints. A box with constraints is nothing else than a regular box, which gives us access to its bounds, so to the width and the height, which we just need to calculate the boundaries of our image, so until where we are allowed to drag the image and not further. And this box with constraints will have a modifier of fill max width on the one hand, and on the other hand it will take the aspect ratio of our image. In my case that's 1280 pixels by 959 pixels. Please use your image dimensions here, of course. I've already included my image here in the drawable folder, so please make sure you also have the same, at least a comparable image which you want to zoom into. And in this box with constraints, we have our image. The painter is our painter resource to load an image from our resources, r.drawable.current in my case. And then the content description is, let's just pass null here. And the modifier is modifier.fill max width. And then the magic happens inside of this graphics layer. So the graphics layer allows us to just transform a composable in all kinds of ways. So on the one hand, we can change the scale X, and set that to our scale Y, set that also to our scale. And we want to change the translation X, so the X offset is equal to our offset.x, and the translation Y, offset.y. And that itself won't do anything yet, because we don't change the offset and the scale yet. But what we can do is, we can define a magic thing called a transformable state. State is equal to remember transformable state. And that takes in a lambda, which gives us the zoom change, the pan change, and the rotation change in form of parameters. And Compose handles a lot here for us, since we don't need to calculate the zoom change, pan change, and rotation change on our own. We just need to update our state accordingly. So what we can do here is, we can say scale is equal to our scale multiplied with our zoom change. So if the zoom change is, for example, 1.1, so we zoomed in by 10%, then we multiply our current scale with the new zoom change, so 1 times 1.1, which results in 1.1 in scale. So we zoomed in by 10%, but we want to have some kind of boundaries for that, for which we can use coerce in. And here we can pass a minimum value. So we want this zoom to be 1f at minimum, so we can't really zoom out if we already have the original size of our image. And the maximum zoom is, let's say, 5. And we of course still need to do more here for the offset, but we can already try this out. If we go down and say transformable, and we pass in our state, so that this transformable state really listens to these zoom, pan, and rotation events on our image composable, then we should already see that we can zoom in, but we can't move the image yet. So you can see, I zoom in, and yes, that's working. I can't move yet, but we can zoom further out than the image originally takes, but we can zoom in up to 5 times. Okay, you can see how easy that is. The offset is now a little bit trickier, because we could of course say, okay, our offset is equal to, or is plus equals our pan change, which is also an offset. So we just add that change to our offset, and then we should be able to already be, we should be able to see that this works. If we zoom in, we can move, but you'll also see that we can move past the bounds of the image. That's of course not what we want. And we now need to find out the minimum x coordinate until we want to be able to move it, the minimum y coordinate, the maximum x coordinate, which is the end here, on the end of the image, and the maximum y coordinate, which is the bottom of this image. And then we want to also call cores in for the pan change, or for whatever we set the offset to, and make sure that the offset is within the bounds. And for that, we need to calculate the extra width. So basically the width, which is currently not visible. So if we zoom in on the image, then obviously parts of the image are not visible at the moment. And the width of these parts together is described by this extra width, which is scale minus 1 multiplied with constraints.max width. And extra height is equal to scale minus 1 multiplied with the constraints.max height. Why scale minus 1? Well, if our scale is 1f, so that is the very initial situation. If we relaunch the app, then now we would be at a scale of 1. Then at this point, there is no extra width because nothing is actually overlapping anywhere. So 1f minus 1 would be 0. So we would end up with an extra width of 0. But if our scale is 2, for example, so we're zoomed in a little bit, then the extra width would be 2f minus 1, so 1 times our constraints max width. So then half of our constraints max width would be overlapping at the left side and half of it on the right side. And that is how this formula, or where this formula comes from. And then we can calculate the max x coordinate. So the rightmost x value that is allowed, or till where we are able to offset this. And this would be our extra width divided by 2. Because in the end, we have 2 sides which are potentially overlapping. And one of these is on the right side, one of these is on the left side. And we have the max y as well, which is extra height divided by 2. And then we can say our offset is a new offset. The x value is our current offset x. We add our pan change.x on top of that, and then coerce that in minus max y, minus max x, and plus max x. You can duplicate this for y as well. It's exactly the same, just that we replace everything with y. Max y and max y. And if we now also delete this line here, of course, if we now relaunch the app, take a look, then we can zoom in. If we now move this, then now we can't move past the bounds of the image anymore because we established this formula and we have this coerce in function. Something you will notice though is that the further you are zoomed in, the less a little swipe has an impact on the offset, which is quite weird. But the zoom actually also has an effect on how many pixels are moved. And if you want to avoid that, you would need to multiply this pan change here with the scale as well to make it dependent on the scale. So if the scale is really large, like 5f, that means we're really far zoomed in, then we want to add more of this pan change than if the scale would be just 1. And here as well. If we then relaunch this one final time, then we should be able to see if we zoom in, we can still move this image pretty quickly, just as we would expect. So far so good, but what I also wanted to show you is rotation, of course. For that, we can simply go up here, copy paste our scale and name it rotation. And then in our function, we can make sure that our rotation change, actually our rotation plus equals our rotation change. I'm not sure if the rotation is an absolute value here or if it's a percentage value, but I think plus equals should be fine. If we scroll down, we then want to say our rotation Z, so around the Z axis, which goes inside the screen, we want to rotate, and that will be our rotation degrees. Okay, let's try this out. Take a look here, and yes, we can rotate our picture. We can still zoom, but of course, as you see, the boundaries aren't considered anymore, because with rotation, this will be a bit more tricky to calculate that. But if you just rely on the rotation itself, then this is how easily you can implement that in Android Studio with Jetpack Compose. If you feel like Jetpack Compose is still quite complex, you're very interested in that, but it's still quite complex, you're afraid if you're making any mistakes, then I got a free PDF for you, which summarizes 20 very deadly mistakes you should definitely not do in your Jetpack Compose projects. Get that PDF for completely free down below, and I wish you an amazing rest of your week. Thanks for watching, and I'll see you back in the next video. Bye bye.